Hi guys, Maing Adlaw. Welcome to NatzMath TV. If you are new to this channel, please do not forget to subscribe, like, and share. So for you to do that, I will give you 5 seconds to subscribe. Okay, your time starts now. 1, 2, 3, 4, and 5. So for today's video, my presentation is about solving systems of linear equations in two variables by comparison method. So this is now the part 3 of the 3 series in solving systems of linear equation in two variables. So the first part was about by substitution method, the second part was about elimination method, and this time we will have comparison method. So how do we solve systems of linear equations in two variables by comparison method? Okay, before we proceed to our examples, let us have first this objective. At the end of this video, you should be able to solve systems of linear equations in two variables by comparison method. So how do we solve systems of linear equations in two variables by comparison? So let us proceed to our example number 1. For example, you are given this set of equation. We will have 4x plus 2y equals 10 and x minus y equals 13. So we will name this first equation as equation 1 and the second equation as equation 2. Now to solve for systems of linear equations in two variables by comparison, first things first is we need to decide which variable we are going to solve first. For example, if we are going to solve for the variable x, we will have to have an initial value of y in terms of x. Or vice versa, if you want to solve for the variable y, we will have to have an initial value of x in terms of y. Okay, so we have to solve for x. For this example, we'll have to solve for x. We need to express each equation to y in terms of x since we have to solve for the value of x. So y in terms of x for equation 1 and y in terms of x for equation 2. Now we have to start with equation 1. Now our equation 1 is 4x plus 2y equals 10. Now, since we need to solve for y in terms of x, so we need to eliminate the 4x here so that only 2y or y shall remain at the left side of the equation. So how do we eliminate 4x here? Of course, we need to subtract 4x. And of course, since we need to subtract 4x on the left side of the equation, the same thing we need to do, we also need to subtract 4x at the right side of the equation since this is an equation. So whatever you do to the left side, is the same thing that you need to do to the right side. So this will become, to eliminate the 4x, since we have to eliminate the 4x, of course, we need to subtract 4x. And of course, since we subtracted 4x here, we will also subtract 4x at the right side. In this case, we have cancelled out, or we can cancel out the 4x because 4x minus 4x is 0. So what remains at the left side of the equation shall be the 2y. Then we just simply copy 10 minus 4x. Now, since we are only going to solve for y in terms of x, so we need to eliminate the 2. So in order for us to eliminate the 2 as the coefficient of y, of course, we need to divide both sides of the equation by 2. So that's why we have here over 2 and over 2. This time, we can cancel out the 2. So what remains at the left side of the equation would be y equals. So this is 10 divided by 2 is 5. Then we copy minus. 4x divided by 2 is 2x. That's why our y in terms of x, or the initial value of y in terms of x, is 5 minus 2x. And I will name this equation as our equation 3. So our original equation is equation 1 and equation 2. So this time, we will name this equation as equation 3. Equation 3 is coming from equation 1. Now, next, let us proceed to our second equation, which is x minus y equals 13. The same process. So we need to express this equation 2y in terms of x. So the same process, since we have the x here, we have to eliminate the x by subtracting, of course, x. So that will become 0. So since we subtract x at the left side, we will also subtract x at the right side. In this case, we can eliminate now the x, so that is x minus x, which is 0. So what remains at the left side of the equation is negative y. Then equals, we copy 13 minus x. This time, our y is negative. We have to see to it that when we solve for the value of our variable, the unknown variable should always be positive. In this case, since our y is negative, we have to either multiply both sides of the equation by negative 1 or divide both sides of the equation by negative 1, either the two. In this case, we multiply both sides of the equation by negative 1 so that we can have a positive y here. So when we multiply negative 1 times negative y, of course, negative times negative is positive. And when we multiply negative 1 times 13 is negative 13. And when we multiply negative 1 times negative x, that gives us positive x. So therefore, for the second equation, our y in terms of x is negative 13 plus x. So we have, this is our equation 3. This time, this will be our equation 4. Okay, equation 4 is of course is taken from equation 2. So we already have equation 3 and equation 4. Next step is to equate the two initial values of y in equation 3 and equation 4. So this is our y in equation 3 and this is our y in equation 4. So what we need to do is to equate these two initial values of y. So this shall become, so our y in equation 3 is 5 minus 2x, and our y in equation 4 is negative 13 plus x. So this time we can now solve for x. So how do we do this? All constants should be at the right side and all variables should be at the left side. So we have here the variable negative 2x. We also have here the variable x. We will subtract x here. So this will be 0. Of course, we will also subtract x here. The same process with 5. Since 5 is constant, so this will be transferred to the right side. We will subtract 5 here. We will also subtract 5 at the right side. So this shall become, we have here the 2x or negative 2x. We copy negative 2x. So our x here, we subtracted x here. Of course, we will also subtract x. So equals, we copy 13. Since we subtracted 5 here, this will be 0. So we also subtract 5 at the right side. So this is now our resulting equation. This time we simplify. Negative 2x minus x is of course negative 3x equals negative 13 minus 5 is negative 18. This time, since we are going to solve for x, we divide both sides of the equation by negative 3 to eliminate the coefficient of x, which is negative 3. So we have, this time we cancel out the negative 3. What remains at the left side is of course the x. Then negative 18 divided by negative 3 is positive 6. So therefore, our x is equal to positive 6. Now to solve for y, we need to substitute the value of x. This time, our value of x is 6 to any of the equations 1, 2, 3, or 4. Any of the equations. So we can substitute in equation 1, or in equation 2, or in equation 3, or in equation 4. So we just simply choose which of this equation we are going to use to solve for the value of y. For this example, we use equation 2. Our equation 2 is x minus y equals 13. So we substitute the value of x to the equation. So that's why we have 6. Instead of writing x, we write 6 minus y equals 13. Now, since we are going to solve for y, we subtract 6 at the left side. Of course, we will also subtract 6 at the right side. So, this will be cancelled out. So, what remains at the left side is negative y. Then, 13 minus 6 is, of course, positive 7. Now, this time, since our y is negative, as I've said, our variable should always be positive. So, we need to either multiply both sides of the equation by negative 1 or divide both sides of the equation by negative 1. So, this shall become y equals negative 7. So if x is positive 6, y is equal to negative 7 for this set of equations. Now to check if our answers are correct, we go back to our original equation, equation 1 and equation 2, and the values of our x and y are 6 and negative 7 respectively. Equation 1 is 4x plus 2y equals 10. We substitute the values. 4 times, instead of writing x, we change that with 6 plus 2 times, instead of writing y, we change that with negative 7. Then simplify. 4 times 6 is 24, and 2 times negative 7 is negative 14. Then 24 minus 14 is equal to 10. So that is 10 is equal to 10. So we got a balanced equation for equation 1. So let's proceed to equation 2, which is x minus y equals 13. We substitute the values, so we will have x is 6, copy minus, y is negative 7. Negative times negative, that gives us positive. So 6 plus 7 is 13, which is equal to 13. So we got a balanced equation for both equation 1 and equation 2. So therefore, the values of x and y are correct. So let's proceed to our second example. We are given the set of equation. Equation 1 is 2x plus 3y equals 13, and equation 2 is 4x minus y equals 5. Now the same process. To solve for y, we need to express each equation to x in terms of y. In the first equation, we express the equation 1 and 2 to y in terms of x. This time, we will solve for y. That's why we will solve for y. We express each equation to x in terms of y. So let us start with equation 1. Our equation 1 is 2x plus 3y equals 13. Since we have to express this equation 2x in terms of y, so we need to eliminate the 3y so that only x shall remain at the left side. So that's why we have the 3y here. Of course, to eliminate this 3y, we will subtract 3y at the left side and subtract 3y at the right side. In this case, we cancel out the 3y. So what remains at the left side is 2x equals, we copy 13 minus 3y. Now, next is to eliminate the 2 so that only x shall remain at the left side. So we will have divide both sides by 2. This will become 2 will be cancelled out. So what remains at the left side is x. Now, this time, since 13 is not divisible by 2 and also 3 is not divisible by 2, we shall leave these values in a fractional form so that it would be easy for us to cross multiply. So we are not going to divide 13 by 2 or 3 by 2. So we shall leave this equation as is. So this is now our equation 3. Equation 3 is taken from equation 1. Now let's proceed to equation 2. Equation 2 is 4x minus y equals 5. So the same, we need to eliminate the y. So to eliminate the y here, we have, of course, since this is minus, so that we can eliminate this y, we need to add y. Unlike here, this is plus, we subtracted 3y. Here, since this is minus, to eliminate this one, we will add y. That's why we have 4x minus y plus y equals 5 plus y. Okay? Then this time, we eliminate the y. So what remains at the left side shall be 4x equals, we copy 5 plus y. Then, we have the 4 here as the coefficient of x, so we divide both sides of the equation by 4 so that we can cancel out the 4. So what shall remain at the left side of the equation shall be x equals the same here, since we cannot divide 5 by 4 or you have 1 here by 4, so we shall leave this equation as is. So this is now our equation 4. So we have equation 1, equation 2, equation 3, and equation 4. Equation 4 is taken from equation 2. Next is, of course, we need to equate the two initial values of x in equation 3 and 4. Equation 3, this is our x. This is the value for x. And equation 2, this is the value for x. So we equate these two values. This is from equation 3, 13 minus 3y over 2, this one, equate to equation 4, which is 5 plus y over 4. This time, since both are fraction, this is what we call fractional equation, we can just simply cross multiply. So we cross multiply and cross multiply. So this shall become, we have the 4 multiplied to 13 minus 3y. So that's why we have here 4 times 13 minus 3y. Then we copy equals. Then we have the 2 multiplied to 5 plus y. Okay? Then we distribute this 4 to the terms inside the parentheses, the same as with 2 to the terms inside the parentheses. That becomes 4 times 13 is 52, and 4 times negative 3y is negative 12y. Then at the right side, we have 2 times 5 is 10, 2 times y is 2y. Now, since we are going to solve for y, we need to have our variable y at the left side and our constant at the right side. So we copy negative 12y. Since we have here the negative 12y, then since we have the 2y here, so to eliminate this 2y, we subtract 2y, so this will be cancelled out. And of course, we also subtract 2y at the left side. That's why we have here the negative 2y. Then equals, we copy the 10. We have here the 10. And of course, 52 here, to eliminate this 52, we need to subtract this one by 52. So this will be cancelled out. Of course, we also subtract 52 at the right side. So that's why we have here negative 52. Then, simplify. Negative 12y minus 2y is, of course, negative 14y equals 10 minus 52 equals negative 42. Then, to solve for y, we divide both sides by negative 14 and also negative 14 so that we can eliminate the negative 14. So what remains at the left side of the equation is y equals negative 42 divided by negative 14 is positive 3. Our value for y is positive 3. Now to proceed, to solve for x, we substitute this value of y to any of the equations 1, 2, 3, or 4. So any, we can use equation 1, equation 2, equation 3, or equation 4. For this example, we will be using equation 3. This time we have here equation 3, which is x equals 13 minus 3y over 2. Since our y is 3, so instead of writing y, we change that with 3. So to simplify, negative 3 times 3 is negative 9. So we copy 13 minus 9 over 2. 13 minus 9 is 4 divided by 2. Of course, our x is equal to 2. That is 4 divided by 2. So if our y is 3, our x is equal to 2 for this set of equations. Now, to check if these values are correct, we have these equations. Equation 1 and equation 2, and these are the values. X is equal to 2 and y is equal to 3. We check for equation 1, which is 2x plus 3y equals 13. We substitute the values, so we have 2 times our x is 2 plus 3 times our y is 3. We simplify, 2 times 2 is 4, 3 times 3 is 9, then 4 plus 9 is 13, which is equal to 13. Now, let us check for equation 2. Our equation 2 is 4x minus y equals 5. The same, we substitute the values, so we have 4 times our x is 2 minus our y is 3. So 4 times 2 is 8 minus 3. So 8 minus 3 is 5, which is equal to 5. So therefore, our values are correct. Now let's proceed to our third example, our last example. So we have 5x minus 6y equals 14 and negative 2x plus 4y equals 12. So we will set this one as equation 1 and this one as equation 2. The same process. For example, we need to solve for y. So again, express each equation to x in terms of y. For example, we need to solve for x. We have to express each equation to y in terms of x. So, bali-bali ra na siya. Now we will start with equation 1. So our equation 1 is 5x minus 6y equals negative 14. So since we have to express this equation 2x in terms of y, so we will eliminate the 6y. So this is negative 6y, so of course we have to add 6y, and of course also we have to add 6y at the right side of the equation. This time we can cancel out the 6y, so what remains would be 5x equals negative 14 plus 6y. Now to solve for x, we divide both sides by 5. Cancel out 5. What remains at the left side would be the x. Now again, since we cannot divide 14 by 5 or 6 by 5, so we shall leave this equation like this. So we will have this equation as equation 3. This is taken from equation 1. The same process we will do for equation 2. Our equation 2 is negative 2x plus 4y equals 12. So again, we need to eliminate the 4y here. Of course, that's why we have to subtract 4y and also subtract 4y. This time we cancel out the 4y. So what remains at the left side is negative 2y and equals copy 12 minus 4y. Then divide by negative 2. And of course negative 2. Cancel the negative 2. What remains is x equals. This time, since we can divide 12 by 2 and 4 by 2, so we can have 12 divided by negative 2 is negative 6, and negative 4 divided by negative 2 is positive 2y. So our initial value of x in terms of y for equation 2 is negative 6 plus 2y. I will name this equation as equation 4. So to solve now for y, we need to equate the two initial values of x in equation 3. This is our equation 3 and equation 4, which is this one. So we have equation 3 is negative 14 plus 6y over 5, copy, equals. Then we copy negative 6 plus 2y. Now this time, this is a fraction and this is not a fraction. Now, what are we going to do so that we can cross multiply? We will assume this expression to have an assumed denominator 1. So that when we cross multiply, that will give us negative 14 plus 6y times 1, the denominator here, assume 1. So that will give us, we have the assumed denominator 1 here multiplied to negative 14 plus 6y, so we copy negative 14 plus 6y equals, we multiply 5 times, of course, this expression, 5 times negative 6 plus 2y. We copy the left side of the equation, which is negative 14 plus 6y equals 5 times negative 6 is negative 30, and 5 times 2y is positive 10y. Again, the same, all the variable y shall be at the left side of the equation and a constant at the right side. So we have the 6y here, of course, we copy the 6y, and since we have the 10y here, we have to subtract 10y and of course subtract 10y at the left side. Then we copy negative 30. We have the negative 14. To eliminate this one, we have to add positive 14, cancel, and of course add 14 here. So that becomes 6y minus 10y equals negative 30 plus 14. Simplify, 6y minus 10y is negative 4y equals negative 30 plus 14 is negative 16. Then to solve for y, we divide both sides of the equation by negative 4 and negative 4. Cancel out the negative 4. What remains is y equals negative 16 over negative 4 is positive 4. So our y is equal to positive 4. The same process. To solve for x now, substitute the value of y to any of the equations 1, 2, 3, or 4. So either of these 4 equations. For this example, we use equation 4. We have here negative 6 plus 2y. Substitute the value. So we have x equals negative 6 plus 2 times our y is 4. Then we simplify. We have 2 times 4 is 8. And last is x equals negative 6 plus 8 is positive 2. So therefore, the values of x and y are 2 and 4 respectively for this set of equation. So to check if this is correct, so let us proceed to our original equation, which is 5x minus 6y equals negative 14, and equation 2 is negative 2x plus 4y equals 12. The values are x equals 2 and y equals 4. So we will start from equation 1. Substitute. We have 5 times 2, our x is 2, and 6 times 4, which is the y is 4. Then 5 times 2 is 10, negative 6 times 4 is negative 24. So 10 minus 24 is negative 14, which is equal to negative 14. We got a balanced equation for equation 1. Let's proceed to equation 2, which is negative 2x plus 4y equals 12. We substitute negative 2, copy, times x is 2, plus 4 copy times y is 4. So negative 2 times 2 is negative 4. 4 times 4 is positive 16. Negative 4 plus 16 is of course 12 equals 12. Okay, so therefore we got a balanced equation for equation 1 and equation 2. Therefore, our values for x and y are correct. Okay, that's it. I hope you have learned something from this video. Thank you and God bless.